Okay, this video is the Dr. Yamashima theory of cooking oils, dementia, diabetes, and obesity. Okay, so where this comes from is Dr. Yamashima is a Japanese neuroscientist who was given the task of trying to figure out why were the Japanese becoming so much more demented from the past. You know, Japan before 1970, they're pretty famous for living long lives and being very healthy. He studied it quite extensively, and he came to the conclusion it's because they're eating way more cooking oils, omega-6 cooking oils, and it's making them fat, stupid, demented, causing brain damage, causing diabetes, and I'm going to explain how some of that works. So if you only wanted to get the main point of this talk, it's going to be don't ever drink alcohol and don't ever eat omega-6 cooking oils, okay? Why it all happens that way is rather interesting, and I'm going to go into that if you want to hear it, but that's sort of the main points about this talk. It also explains why the whole notion that you're going to treat dementia with one pill is ridiculous. There's numerous things converging on destroying brain cells, so the smartest move if you want to optimize your cognitive function into your middle age and older years is learn what they are and avoid them. That's like it is for any disease. Learn the cause and avoid the thing that causes it. Okay, first of all, when you drink alcohol, the first enzyme to process it is alcohol dehydrogenase, and then that converts the alcohol into ethanol or acetaldehyde. Then the second enzyme is in the mitochondria, that's acetaldehyde dehydrogenase, and that will sort of detoxify it. This intermediate here, this acetaldehyde, is very toxic, okay? A lot of Japanese people are deficient, and a lot of East Asians in general, you know, Chinese, Koreans, and Japanese are deficient in this acetaldehyde dehydrogenase, ALDH we'll call it, and they get flushing if they drink alcohol, and they're also at increased risk to become demented. And what I'm trying to say is these cooking oils, you know, the old AC/DC album here, Highway to Hell, cooking oils really destroy your health. You want to avoid them. There was sort of a stupidity that came about in the 1960s. After the 1950s, when Ansel Keys showed that saturated fat was really bad for our health, there was a move towards, oh, well, we can eat all these omega-6 fats. But that turned out to be wrong. That was a great album back in the old days. I used to listen to that. It was good wrestling music, AC/DC. Okay, so anyways, Yamashima has this whole entire theory of what causes destruction of brain cells. And it's pretty interesting stuff. This is his most recent paper. So his first name is Tetsumori Yamashima, a Japanese neuroscientist. He's written a whole bunch of papers, and he has developed this theory called the Calpain-Cathepsin hypothesis. You really could call it the omega-6 cooking oil HydroxyNonEnal Calpain-Cathepsin hypothesis. All right. I'm going to go over this with much better detailed drawings from his research papers, but just to give you the overview, when people eat omega-6 fats, typically they're cooking oils and they're frying some food. The frying of the food will produce what are called HydroxyNonEnal, sometimes just the way the company has processed it themselves. These HydroxyNonEnals are toxic aldehydes. They will bind to something in brain cells called HSP70. That means heat shock protein number 70. Heat shock protein number 70 has a very important job in brain cells. It's a chaperone protein, and it also stabilizes lysosomes. So when this gets carbonylated, bound to hydroxynonenal, that will damage the heat shock protein and make it more attractive to an enzyme called calpain, which cuts the HSP in half, and then the lysosome can no longer be stabilized. It ruptures and it digests the brain cell, and the brain cell dies, okay? So this is an important point because if you want to avoid cognitive impairment, dementia, brain fog, you want to avoid all these things. So never eat anything with omega-6 cooking oils in it, okay? Never drink any alcohol. All that 1 cup a day stuff is nonsense. All right, so now I'm going to, kind of break it down into the parts. That was just the overview right there. So when somebody drinks alcohol, it comes into our body, goes into the cytoplasm. Alcohol dehydrogenase, first of all, starts to reduce it to acetaldehyde. Actually just converts it to acetaldehyde. Let's leave it at that. And then acetaldehyde goes into the mitochondria, and then it's converted to acetic acid. It's actually being oxidized. Okay, during this time, NADH is formed in this reaction and in this reaction. So there's really only 2 big steps here. If a person drinks a whole lot of alcohol, then the cytoplasm ADH can't handle it, and it'll go into the endoplasmic reticulum, And the point being is when it goes down this path, so this is why binge drinking is really bad, you'll produce reactive oxygen species. Those are free radicals with an unpaired electron in their outer orbital, because those will damage the membranes and cause lipid peroxidation of membranes. And that lipid peroxidation of membranes will lead to the formation of HNE. HNE is HydroxyNonEnal. Okay. And again, the people who are a lot of East Asians are deficient in this enzyme, or only partially deficient, and so they'll get Asian flushing syndrome. Here's HydroxyNonEnal. It's really 4-hydroxy. So on the fourth carbon is the hydroxy group. Non means 9. There's 9 carbons total. Enal means there's a double bond. So there's a double bond. Al means it's an aldehyde. So it's a carbonyl group carbon just bound to a hydrogen. Okay, so anyways, HENE is freely diffusible through membranes. It goes right into the mitochondria, including in the brain, and it will inhibit ATP synthase of mitochondria energy production. So it's toxic to brain production of energy. The anatomy of a fat, basically you can count from the carbon farthest away from the carboxylic acid. That's the omega end. And then, 1, 2, 3, that would be an omega-3 fat. 4, 5, 6, this would be an omega-6 fat. The fatty acid is polar. The rest of it, the hydrocarbon chain of just carbons and hydrogens, is nonpolar. So this is not soluble in water. The polar component is soluble in water. The fact that it has both properties, being hydrophobic from its carboxylic acid and hydrophilic from its carboxylic acid and hydrophobic from its hydrocarbon chain, that makes it amphiphilic, meaning that it's both polar and nonpolar, and it can be like a emulsifier, able to exist in both forms, in a lipid environment and in a polar water environment. Okay, so a sat fat has no double bonds. A MUFA means monounsaturated, meaning one double bond. A PUFA is polyunsaturated, having 2 or more double bonds. This is called the methylene bridge carbon in between the double bonds. That hydrogen is very much at risk to getting plucked off and undergoing lipid peroxidation. Okay, oxidation products from omega-3 and omega-6 fatty acids. I really haven't studied the omega-3 fats and what they get broken down into, but we know that omega-6 fats get lipid peroxidized into all kinds of harmful things like HydroxyNonEnal, HNE. And I would expect there's problems with omega-3s. I haven't studied it yet, but PUFAs in general are very vulnerable to undergoing lipid peroxidation. The more double bonds, the more something undergoes that. And these things like DHA and EPA, they're all got a whole bunch of double bonds, so I would expect them to have problems. Oops, I removed the wrong thing. All right, so what's the point? We showed how NADH was produced in those reactions for detoxifying alcohol, but when you produce too much NADH because the patient's binge drinking, what ends up happening is a lot of enzymes are dependent on NAD plus versus NADH, and they start running backwards. They run backwards in glycolysis, backwards in the metabolism of pyruvate, and that's really, I joke that this is bad company. The other major metabolic things that run pathways backwards are cancer starts running glucose metabolism through the electron transport chain backwards. You run into the things going backwards with diabetes, and inhibition of electron transport. So what I'm trying to say is alcohol is bad company. Cancer and diabetes, you don't want to drink alcohol. Okay, saying let's get stoned, let's get plastered. That's stupid. You're just poisoning your brain. It's stupid. Okay, because you also will block gluconeogenesis because you're running all these enzymes backwards. You can get fasting hypoglycemia with alcohol ingestion. You can get ketosis because you're running some Krebs cycle enzymes are not working. Accumulation of lactic can also contribute to lactic acidosis. Okay, but we're going to get to much better stuff than this. This is just warm-up intro stuff. Okay, the high NADH to Na plus ratio. The bottom line is you can overwhelm your liver detoxification capacity, and these toxic aldehydes can start accumulating. You can also produce a lot of reactive oxygen species, lipid peroxidation, and more HydroxyNonEnal. So another point about HydroxyNonEnals is you can get them just from your diet, from the cooking oils, or from the metabolism of alcohol. You can produce them just from lipid peroxidation. That's endogenous, intrinsic production of them. Other problems with alcohol it's all bad. Alcohol also causes leaky gut. It causes high blood pressure. It's all bad. Okay, this is just showing what lipid peroxidation is all about. The methylene bridge carbon in between the double bonds, it's at risk of being plucked off. It's plucked off here, and a peroxide with two adjacent oxygens, and it's a free radical with an unpaired electron. It's outer orbital. This can have chain reactions that destroy plasma membranes. Oxidative stress just means more oxidants than antioxidants, so that's what you get from being like iron overloaded and not having enough antioxidants because you don't eat enough meat. Alcohol just destroys the brain. It pickles the brain. Alcohol brains are shrunken. It also causes a tremendous amount of fatty liver, worse typically than just from eating your processed foods. This is just a reminder about a lot of Asians. Like half of the East Asians are at least partially deficient in acetaldehyde dehydrogenase enzymes, so they're more vulnerable to the toxicity of alcohol. They're also more vulnerable to becoming demented from cooking oils. As a person gets older, they're less able to clear these HydroxyNonEnal toxic aldehydes from their blood. They gradually just accumulate more of them in their blood. Okay, so hydroxynonenal is typically present in cooking oils, even if you don't heat them from the company processing them. They're much worse when you fried food. They're also found in beta amyloid plaques. He actually thinks they're a major cause of dementia in all populations, but okay, smart move is just don't ever eat them. His theory is called the Calpain-Cathepsin hypothesis because it's once you've gone through this cascade of reactions to lyse your lysosomes and they break apart, then cathepsin is like the monster getting free from the lysosome going around digesting the cell. So it digests itself and it dies. Okay, we talked about when the metabolite of omega-6 oils processing hydroxynonenal binds to HSP, then it makes HSP, the heat shock protein, more attractive to calpain, and that'll destroy it. I'll show you that in a picture in just a moment. Increased cytoplasmic calcium, which comes from a bunch of things. All these excitotoxins like MSG, MFG, glyphosate, aspartame, psychological stress, caffeine, they all contribute to higher cytoplasmic calcium as well as excess dietary sodium and increasing the likelihood that that's going to become activated and then cause these problems. Okay, here's probably the best picture this talk has about what's going on inside the cell. Okay, so what's happening here is first of all, you've got something activating the cell like glutamate, MFG, aspartame, caffeine, sleep deprivation, stress, causing opening of the calcium channels. So the calcium channels are open, elevating cytoplasmic calcium concentration, and that elevates the amount of activity of this enzyme calpain. Activated by calcium, and it's a pain when it's activated. It'll cause problems for the cell. HSP is heat shock protein, and it's a chaperone, meaning that it helps proteins to fold correctly. It also carries unfolded, damaged, used up proteins that need to be recycled, misfolded proteins. It carries them to the lysosome for recycling. It binds to the lysosome membrane and it stabilizes the lysosome so it doesn't break apart. All that stuff is really important for the cell. What happens is when hydroxynonenal is present in high amounts, it'll grab onto one of these heat shock proteins and bind to it. And that is the equivalent of turning HNE into a foxy babe for the calpain protease. Calpain protease will then bind to HSP and it will cut it in half. When it cuts it in half, it then deactivates HSP. When HSP is deactivated, it can no longer work as a chaperone and it can no longer stabilize the lysosomal membrane. So this lysosomal membrane will break apart, and then this digestive enzyme, cathepsin, protease, it'll break out into the cell and just start randomly digesting things, and that will kill the cell. Okay. So if the person would have just avoided the omega-6 cooking oil in the first place, they could have avoided going down this path. Okay, so here's slides from the work of Tetsumori Yamashima. Basically, here's a normal lysosome. It has a relatively well-delineated borders. Once a lysosome is ruptured, now you got these sort of nodular, lumpy, bumpy borders, and you have adjacent increased density from its contents spilling out and causing problems to the adjacent materials in the cell. So that's a lysosome. Cathepsin is now free and it starts to digest the cell. So that's what it's all about. So that's why it's called the Calpain, because Calpain enzyme led to the lysosome breaking. Cathepsin got out, so Calpain-Cathepsin hypothesis of neuron degeneration, death, and dementia that follows. Okay, some other things. Older people tend to have less antioxidants, less ability to detoxify all this stuff. H&E can come either from, like we said, the heated cooking oils, or it can be endogenous, just come from the body due to other sites of lipid peroxidation, which we all have some, and people get more of that if they have a poor diet and lifestyle. Chronic mild brain ischemia, like the mouse equivalents we talked about with Delatorre's theory, chronic mild brain ischemia, for whatever the reason, overtreated hypertension, diabetes, hypertension, damaging capillaries, high-fat meals, high dietary sodium, they will lead to decreased function of acetaldehyde dehydrogenase, and that decreased function makes a person less able to detoxify the toxic aldehyde, HydroxyNonEnal. Persons with chronic mild cerebral ischemia due to poor blood flow to the brain, they'll have 7 times increased amount of Calpain activation. So again, it's kind of a reminder of Delatorre's theory, okay? And then we talked about the Calpain will then cleave the HSP. Carbonylated HSP just means H&E bound to HSP. And that will then, like we said, lead to the inability of HSP to protect the lysosome. Lysosome ruptures, Cathepsin enzyme release, Cathepsin auto-digests the cell. Okay, these are just some of the references if you're curious. And I got a couple more slides left that what Yamashima says is this also destroys neurons in the brain in the arcuate nucleus of the hypothalamus, which is the hunger center, and the person becomes less able to control their hunger. These are just theories of why people get fat, because they're addicted to the food. They reach the bliss point, make it taste so good with salt, sugar, fat, and MSG, because they eat high caloric density foods without the fiber, because they got estrogenic chemicals programming them to be fat. And MSG also can be toxic to the hypothalamus and have a bit of an excitotoxin effect on it, excitotoxin effect means overactivating a brain cell till it outdoes its oxygen glucose supply and the cell dies because it can't meet its metabolic demands. Okay, so Tetsumori Yamashima, his damage to the hypothalamus hunger center helps explain why some chronically obese people, they just can't control their diet and they have a hard time. Even if they start eating healthier, they just can't do it anymore. Tetsumori Yamashima also showed the destruction of brain cells in the arcuate nucleus. I mean, this is a gradual process that happens over the course of decades, but that's pretty scary to be losing neurons in your hunger center, meaning that eventually they'll never be able to control their hunger. That's why a person should get their act together. The sooner the better before the process becomes irreversible. He did experiments too where he's working with monkeys, and he found that their exposure to HydroxyNonEnal would lead to destruction of their pancreatic beta cells, the ones that make insulin, through the same mechanism. So even if they're not acetaldehyde deficient, they're still vulnerable to this stuff. So yeah, you can't really defend that well against omega-6 oils. When you eat them in large amounts, you're at risk for these problems to happen and just get worse over time. So the only smart move is don't eat that stuff. Let's see. Toxic aldehyde theory. Oh, causes of beta cell dysfunction. Of course, excessive saturated fat, excessive any type of fat increases eventual pancreatic failure of the beta cells and increase amount of insulin resistance in type 2 diabetes. You first accumulate fat in the skeletal muscle, then you accumulate it in the liver, then you accumulate it in the pancreas, and that's all part of beta cell failure. These are some references on the subject. Tetsumori Yamashima has what you would call the toxic aldehyde theory of beta cell destruction. Okay, so anyways, the bottom line is you want to minimize your intake of dietary fat, especially omega-6 fats, cooking oils, in terms of causing diabetes. But sat fat's also quite bad for causing diabetes. Here's just showing destruction for the same process, Calpain-Cathepsin theory of Yamashima, destroying cells in the hippocampus in the memory center. So this is a contributor to dementia. I don't think it's the main thing because people can become demented even if they don't eat omega-6 cooking oils, but it's part of the process. Okay, let's see. And these are things you can do to avoid beta cell failure. Well, don't eat any oils. Don't eat anything from animals. Eat a low-fat version of the vegan diet. Um, get your exercise. Get your sleep. So anyways, this guy Roy Taylor has some really good work on diabetes. We'll talk about that in a separate lecture. But I just wanted to share with you, this is the Tetsumori, Japanese neuroscientist, theory of omega-6 cooking oils going to hydroxyNonEnal, going to Calpain activation, going to lysosomal rupture, going to release of cathepsin from the lysosomes and autodigestion of the cell, killing the neuron, and this being a cause of dementia. It's a rather interesting theory. It's kind of brilliant. And what does it do? If that don't motivate you not to eat omega-6 oils, I don't know what will.